So welcome back at Ask the Professor, and we like to discuss today about maintenance, because there are nice really questions about how to manage maintenance, and I think that's exactly the point. Therefore we are outside at the university campus and looking here at the tramway and also used as a bus way. And then you can have the question how to install and how to do the maintenance, for example, all the assets we have. So I get a question, for example, what's the question on mismatch of life expectancy of modern railways systems? And I think it's a good question that you have to make the choice, like what asset has this lifetime, a lifespan, and when do you have to renew and when do you have to replace everything? There was the other question, how to make the difference between replacements, renewal and maintenance. I think exactly how to see it over here. You see the rail bars, you see the plates, you see all kinds of assets you have to maintain. And of course, when you look at the rail bar and also the concrete slab track, you have different ways of lifetime and how to make the right decision. And I think exactly what we have to do in every country or every system on itself. Because you have to make the choice, what should I do? What is more expensive, for example? When you have a lot of money to take this out of order, then it is better to say, okay, one corridor, I do the maintenance or I do the replacements in one time. That's more beneficial, of course. But when that's not the case, and it is easy to go in track and replace, but that's not the case in this case, but then it's easy to do some maintenance in times, in a higher frequency, for example. So that's exactly the case, how to make this balance, and that's depending on the efficiency, the life cycle of every asset, and how to make that combination. And that's real system engineering. Good luck with that. So welcome with another question about monitoring. And I get a question like maintenance regime and the right balance. And I think that's a good question, because what is the right regime to do monitoring? You can do monitoring out of the track. What I'm standing here in a track here at the University Laboratory of Railway Engineering, and we can see what kind of devices you do, but the negative effect is you have to go always in track on the spot and do some measurements. For example, we have here our hand turbometer, so we can do some measurements on the track, especially on the running band, to see what is the friction coefficient. So what is the right idea? And I think the best idea is not to go in track, what I'm standing here, for example, and do my job, but better is to go on board of a train, on a running train, just in an operating train like passengers or a freight train, just in the schedule, and then you do all kinds of sensors on board. The question you could give is, yes, but wait a minute, what about the accuracy of these sensors? Because the sensors are not that accurate than when you compare that to the real measurement train you have once or twice a year. I fully agree, but there isn't a trigger in between, because it is possible that you can see with small sensors exactly what is ongoing in the track. And that could be just a trigger, is this right or wrong? And that could be enough to make some decisions to do maintenance. And then especially on the spot, and it is even better to have a picture of your rail network every day than every 6 months or 12 months. I think that's much better. And when you have a trigger, then you have also time to plan in the right maintenance regime or the maintenance actions or renewal to do the right thing in your track. Another question, valuable question, what you get to me, and I really appreciate this, what about the real onboard monitoring systems and how to do that for track? So the question is, what kind of onboard monitoring is already used in the industry? And I think that's a nice question, because at the laboratory what we have, and also on our measurement coach on the CTO of TU Delft, it's nice, but it is still on the laboratory side, you could say. But when you look at the Xbox acceleration, it's still in the markets available, and you can just do the analysis on a daily basis when you put that on board of a running train, in an operating train, as you know, and you can sit on like a passenger, or in a freight train. So it is already available, so you have to maybe to search for that. The technique is there, now you have to, the difficulty is how to bring these sensors, what we did the research on, how to bring that on board of a rolling stock owner. I think that's really an issue, how to do that. Because why should the rolling stock owner help you to install all kinds of devices in their train to help you as an asset manager, for example? It's a good question, and I think that's the real problem, how to make it more easily on the market. But still available. Xbox acceleration is one. Another one is, for example, you could make pictures or videos, video streams on the track. You can also make pictures, also sound is helping you, and you can also use all kinds of devices to combine, so you have big data, for example, to make more data connected to each other to get really information out of it, and that is a little edge beyond than we had before when you're just walking alone in the track. So yes, there is some progress in how to get onboard measurement systems, analysis systems. They are there, but it is still coming and it is in an early stage. The last question for this week is about what are the real parameters to steer your maintenance? And I think that's really an issue. And how it's also hard to say what is the right parameters all over your own network and how to differentiate or not. I think that's a really a heavy question to answer. For example, when you have here in our laboratory, we have a small model about a ballast track with rail sleepers and small ballast. You can also say, okay, how much this will degenerate? Is that because of the weather, the conditions? Is that because of the construction itself, or is it by corrosion, or by the load we have, for example, axle loads, or maybe we have problems with the wear? That's the right discussion. I think you always have a different case in every spot in your network. So you could say, on every spot I have to differentiate. But another way is, yes, nice, but how to organize this in operations, like how to organize the maintenance just in time, just on the right spot. And therefore you need a balance between, do I the right maintenance on every spot, on every asset in your own network, or just you say, no, on one corridor, we just decide on every 50 megaton, for example, we do some tamping or we do some grinding or whatever. And that's the right decision you have to make. And mostly that's based on practice and also based on what kind of rolling stock is running over. For example, when you have monoculture, just one train type, you get special wear or special maintenance actions needed for that typical train. And therefore you need this balance. And this balance is not easy to say this is the right recipe. The only thing is you have wear and you have stretches, for example, in your steel constructions. And what is the regime you like and how to manage that in that regime. So wear and stresses are really important to understand for your maintenance regime. So thank you for all your questions. I really enjoyed. Hopefully you do also. Hopefully you learn something about my small lectures and also about the MOOC itself. A few weeks to go, so good luck with that, and hopefully we see you back on the professional education courses after this MOOC, because then we go in more depth and with real cases, and also you can help each other how to learn more in depth about system engineering on railways. So see you soon, hopefully. Good luck.